Before we start looking at product types in Haskell, let's cover some theory. In mathematics, there is a concept known as a Cartesian product. The Cartesian product of two sets is defined as the set consisting of all of the possible combination of values. Let's look at an example to illustrate this. Suppose we have two sets, A, which contains the values 1, 2 and 3, and B, which also contains the values 1, 2 and 3. We can create a table to enumerate all possible combinations of values for both sets. Here, the first column contains all possible values of the set A in red, and the first row contains all possible values of the set B in green, and the rest of the table shows all possible combinations of values. So the Cartesian product of the two sets would be equal to the set which contains all of these values, which I have shown here. Now suppose we declare a variable x which has the type of a 2-tuple, with the first and second elements both being ints. The value of x could be any possible combination of an int with an int. We can enumerate all of the possible values in a table, just like before. The triple dots represent all of the missing values until either the minimum bound or maximum bound for an int. So what we have here is a product type. It is called a product type because the set of possible values which it can take is defined by the Cartesian product of the possible values for each type. Tuples are inbuilt product types within Haskell, which we have seen before, with their own special syntax of being defined within brackets, with each type in the type signature or each value in the value definition separated by a comma. Here's a question for you. How can we represent a date in Haskell? Well, one of the ways in which we could do it is to create a value of a 3-tuple of ints, like so. As you will see, this is not a good way, but it is a way nonetheless. Here we have created a date with the 3 constituent parts being made up of ints. There are many problems with using a tuple like this. Firstly, there is no way of knowing from the type of int that it is supposed to represent a date. This is just any triplet of ints. Secondly, there is no way of knowing from the type which field is supposed to represent the day or month or year. Unless you have some documentation somewhere which states, for example, that the first int is the day, the second is the month, and the last is the year, then there is no way for someone to know that. And even if you have that documentation, it could just as easily be missed, and people can use it wrong. Also, since everything is an int, there is no way to prevent invalid values being used, such as negative numbers for the day or month. All of these problems and limitations help explain why it makes sense to define our own types to describe our data, rather than relying solely on the inbuilt types. We'll use this idea of a date type as a running example to explain a number of concepts which relate to types in this module. Let's move on. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.